Let's go ahead and start section 1.1, variables and expressions. We're going to begin by filling in the first 9 definitions on our Cornell note sheet for chapter 1. The first definition is variable. Variables are symbols used to represent values. For example, if we had a 4x, x is the variable. We use variables a lot in algebra, all the time. An algebraic expression, the second definition, is defined by numbers and variables combined by operations like addition, subtraction, multiplication, division, but definitely no equal sign. If it has an equal sign, what does that make it? It makes it an equation. So here's an algebraic expression: 4 plus p over q plus 3x. As long as there are no equal signs, then it could be an algebraic expression. Factors. Factors are values that are being multiplied, or quantities. Values that are being multiplied. For instance, if we wanted to know what the factors of 20 are, one of the sets of factors could be 5 times 4. 5 is a factor, 4 is a factor. 1 times 20. 1 and 20 are both factors. 2 and 10 are both factors. They get multiplied together to give us 20. So those are factors. Product. The product is the result of multiplication. So when we do 5 times 4, the product is 20. Power. A power is a term with an exponent. So x to the nth power, or 3 to the third power, we call that. So sometimes the exponent is called power, but sometimes they call that whole thing a power because it has an exponent on it. The base is the number or variable being multiplied. Multiple times. So, if we are doing 2 to the third power, 2 is the base because it means 2 times 2 times 2. 2 is the thing being multiplied multiple times. Exponent is the number of times the base is being multiplied by itself. So 2 to the third power, the exponent is 3, and it's being multiplied by itself 3 times. Okay? Evaluate means to find its value. So if we want to evaluate, must move this up. Okay. To find its value. If we want to evaluate 2 to the 6th power, then that's going to be 64. That's what we get when we evaluate it. And the last one in this section, a verbal expression, is just going from numbers and operations to words. So a verbal expression would be the sum of 12 and 3. The sum of, let's say, 12 and x. That would be a verbal expression. Now, we also want to talk briefly about some basic fraction operations before you get into your practice problems. So let's do a couple of fraction problems here and just remind you of what you do in each of these problems. If we want to, so on your notes you could write 1.1, variables and expressions. And we took the Cornell notes already, so we're just going to do some sample problems. Fractions. Fraction review. So A, we want to add. If you want to add fractions, you must have a common denominator. So you need to get a common denominator first. In this case, it happens for adding or subtracting. We would get a common denominator of 10. So we get 5/10 plus a negative 6/10. And 5 plus a negative 6 is going to give us a negative 1/10. This guy is large and in charge, so we keep the sign of that number, and we actually just subtract these numbers. So we need a common denominator. When we add or subtract numbers that have fractions that are mixed numbers, like 4 and 2/3 plus 6 and 1/6, some people think you should change those to improper fractions, but in fact it's going to be quicker to just find a common denominator for the fraction. So we'll leave 4 alone, and this becomes 4 and 4/6 plus 6 and 1/6. Now add the whole numbers to get 10, and 4/6 plus 1/6 gives you 5/6. That's much quicker than changing this to an improper fraction, this to an improper fraction, finding a common denominator, adding them together, and then having to change it back to a mixed number. So do not change to impropers. Okay, what about multiplying and dividing? A quick review on multiplying and dividing. We've got the multiplying. Well, we'll start with the division problem. 12/5 divided by 4/25. We do not need a common denominator. No common denominator. Okay, no common denominator. So what we want to do is first change to multiplication by flipping the second fraction. So the 12/5 we leave exactly the same. Change it to multiplication, and we flip the second fraction to get what it's called. It's reciprocal. Reciprocal. And we cross-reduce if we can. So 5 goes into itself once and into 25 5 times. 4 goes into itself once and into 12 3 times. Then we multiply what we have left. 3 times 5 is 15. 1 times 1 is 1. Or we can rewrite that as 15. What do we do if we have mixed numbers and we want to multiply or divide? This is our last example. 2 and 3/5 times 10 and 5/8. We need to change to impropers, in this case, improper fractions. No common D, no common denominator. Okay, so we're going to change this to a mixed number. We do a little C. We do 5 times 2 plus 3. 5 times 2 is 10, plus 3 is 13/5, times the same C. 8 times 10 is 80, plus 5 more is 85 over 8. So the denominators stay the same. We multiply, then add to get the numerator. Now we try to cross-reduce. 8 and 13 are not divisible by the same number, so we leave them alone. 5 and 85 are both divisible by 5. 5 goes into itself once and into 85 17 times. Now we just multiply across the top. 13 times 17 is 221, and 8 times 1 is 8. And you can change that if you want to a mixed number. Let's talk about how to do that. If you want to change that to a mixed number, then you divide 221 by 8, and it goes in 27 full times. And then you figure out how many, what you get when you do 27. Or once you multiply 8 times 27, how many are left over? So it goes in 27 full times. There are 5 left over. And the denominator stays the same, 27 and 5/8. Okay. One final question. What do we do if we're subtracting or adding and we have to borrow? So we'll do that last example. That's E, if we need to borrow. So 6 and 1/6 minus 3 and 2/4. Let's do that, okay? Now, we have to still first get a common denominator because this is still addition or subtraction. So we leave the 6 alone and the 3 alone for now. We get a common denominator of 12. 6 times 2 gives us 12. So 1 times 2 gives us 2. And 4 times 3 gives us 12. So 2 times 3 gives us 6. Now, if we try to subtract this, 2/12 minus 6/12, we can't do that. So we need to borrow from the 6. When we borrow from the 6, that becomes 5, and we're going to borrow 1. Now 1 is equal to 12 over 12. So basically, we're going to add 12. Whatever your denominator is, you add it to your numerator, and that now gives us 14. So instead of 2 plus 12, I'm just going to change that. So it would have been a 2. I'm going to add 2 plus 12 and not cross it out, and I now get 14. Now we can subtract. 14/12 minus 6/12 is 8/12, and 5 minus 3 is 2, and then we do need to finish by reducing this. So it becomes 2. We can divide them both by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So we get 2 and 2/3. Subtracting where you have to borrow. Hopefully that was a good review of fractions, and now we're going to move on to the rest of the section.